Hello dear students of grade 12, welcome back for studying another lesson about one of the other topics of physics book of grade 12. In this lesson I will try to explain the angular acceleration, which is the third physical quantity used to describe rotational motion of an object. Angular acceleration tells us how much angular speed of an object changes in a time interval while the object revolves on a circular path. In another way, angular acceleration tells you the change you get in your angular speed in the regular time intervals. Let me tell you this example just to figure out what I am talking about. Imagine one day you and your friend are going to a race, okay? You and your friend have two cars, and let me tell you this example just to help you to figure out what I am talking about. Imagine you and one of your friends are in a race in a circular path. After you have just started to move, the angular speed of your car is increasing much faster than the way that the angular speed of your friend's car increases. This tells you that you are getting faster and faster in a rate that's faster than or greater than the rate that the speed of your friend's car changes or increases. This tells you that you have a greater angular acceleration than your friend. So let me explain this in this way. To understand angular acceleration, let's understand linear acceleration or acceleration. Linear acceleration is the rate of change of velocity. I am going to give you two examples just to understand what acceleration is. Acceleration is the change in the velocity of an object. This is a car that initially is at rest, okay? Initially is at rest, so initial velocity is 0 meter per second at the initial time interval, which is equal to 0 seconds. After 1 second, the velocity of the car becomes 5 meters per second. This is final. After just 1 second. After another second, the velocity of the car will change to 10 seconds. Okay, 10 meters per second in another seconds, okay? So if you look at here, the velocity of the car is changing, okay? So if I find the acceleration of this car, acceleration is equal to change in the velocity divided by time interval, okay? So I'm going to find the acceleration between these two velocities. So acceleration is equal to delta V final velocity minus initial velocity, 2 minus 1, and it is equal to 5 divided by 1, and it is equal to 5 meters per second square. So look at this result. This result tells us that the speed of the car is added by 5 meters per second each time. Okay? Each time the speed of the car is added by 5 meters per second. So this is the magnitude of the acceleration. Okay? So here the acceleration is positive. So we can say that it shows that the speed, the object is being, accelerated, and we can say that it's moving to east. This is the direction, okay? Or it can be, to north. And if it was negative, it shows that the object moves to, north or south. Okay. Now I am going to talk about angular acceleration. Angular acceleration is the rate of change of angular speed. Angular speed is the rate of change of angular speed. Let me give you two examples. we have two cars. This is one of them, and the other one is this. Okay? We have two bicycles. Okay? They travel on this circular path. Let's consider the initial angular speed of this bicycle is 0 radian per second in the initial time interval 0 second, and then it becomes 5 radian per second in the final time interval, let's say 1 second. And then as the bicycle gets here, the angular speed increases more. Okay? It becomes 10 radian per second in the final time interval, 2 seconds. But look at the other one. The initial angular speed is, let's say, 2 radian per second in the initial time interval, which is 1 second. And the final one is, again, 2 radian per second in the final time interval, which is 1 second. As you see, the angular speed of the bicycle doesn't change. It remains constant. So if I ask you in which of these examples we have angular acceleration or acceleration, definitely in the one that the bicycle travels on the yellow circular path, because the speeds change uniformly or constantly. So whenever there is a change in the angular speed, we have angular acceleration. Okay? Because this object is rotationally being accelerated. So if you consider the driver of the bicycle that travels on the yellow path is you, and the one that travels on the other circular path is your friend, you see that you are becoming faster and faster, but your friend travels with the same angular speed. So what's the difference between these two? Here we have angular acceleration. Angular acceleration. Here we have angular acceleration, but here we don't have angular acceleration. Why? Because there is no change in the angular speed of the object. Now I am going to tell you how to determine angular acceleration. Angular acceleration is denoted by alpha. Okay? Alpha is a symbol, a Greek symbol, used to, represent the angular acceleration. Alpha is equal to the change in the angular speed divided by the change in the time interval. Okay. I think we all know that angular speed is measured by radian per second, or degree per second, or revolution per second. And this one is measured by second. So we can say that alpha has 3 units: radian per second square, and degree per second square, and revolution per second square. So these are the units of angular acceleration, but radian per second square is the unit that we use every time. Okay, it's the SI unit of angular acceleration. Guys, this is a very important note that alpha is positive or negative.